Hello my dear students. In the previous live lectures, we were discussed about some basic concept regarding compressible fluid flow and what is the concept of stagnation state, static state, what is the condition for, what do you mean by critical condition, etc. like that, and dynamic pressure concept, what is Crocco number, etc. In this video lecture, we were discuss some problems regarding the first module. Okay. This is the first problem. A test plane has attained a speed of Mach number 2.2 at an altitude of 16 km. Okay, a test plane has attained a speed of Mach number, that is Mach number is equal to 2.2. Okay, Mach number is greater than 1, then it is supersonic flow. At an altitude of 16 km, where the temperature is approximately, temperature of the body is approximately minus 56 degrees Celsius, assuming gamma is equal to 1.4, that is value of gamma is equal to 1.4, and R is equal to, that is R is a characteristic gas constant, R is equal to 290 joule per kilogram Kelvin. Determine the speed of the aeroplane. We have to find out what is the speed of the aeroplane means. What is the speed of the aeroplane means? We have to find out the speed of the object, or we have to find out the speed of the flow. Okay. A test plane has attained a speed of Mach number that is equal to 2.2. That is m is equal to 2.2. Mach number is equal to 2.2 at an altitude of 16 km, where the temperature is approximately 56 degrees Celsius. That is x distance. Altitude is equal to 16 into 10 raised to 3 meter. And temperature is approximately, that is T is equal to minus 56 degrees Celsius. T is equal to minus 56 plus 273. That is T is equal to 217 Kelvin. 217 Kelvin. Okay. Test plane has attained a speed of Mach number 2.2 at an altitude of 16 km, where the temperature is approximately 15 degrees Celsius, assuming gamma is equal to 1.4, that is air as the medium. Gamma is equal to 1.4 and R is equal to 290 joule per kilogram Kelvin. 290 joule per kilogram Kelvin. We have to find out the speed of the aeroplane, that is speed of the object. Okay, we know that Mach number is equal to m is equal to, it is a ratio between velocity of the object to the velocity of the sound, velocity of flow to the velocity of the sound, where A is equal to square root of gamma RT. That is A is equal to square root of gamma is equal to 1.4 into R is equal to 290. It is given 290 into temperature is equal to 270. That is A is equal to approximately 1.4 into 290 into 217. It's approximately 296.82 meter per second. That is the velocity of the sound. That is the velocity of the sound. Okay, we know that m is equal to c by a. Therefore, velocity of the object or velocity of the aeroplane, that is c is equal to m into a. Okay, that is m is equal to 2.2 into a is equal to 296.82. That is c is equal to 653, approximately 653 meter per second. Therefore, velocity of the object, that is velocity of the aeroplane, c is equal to 653 meter per second. That is a simple question. 653 meter per second. Okay, a test plane has attained a speed of Mach number m is equal to 2.2. We know that m is equal to c by a. Therefore, c is equal to m into a. A is equal to square root. A is the velocity of the sound, that is equal to square root of gamma RT. Substitute these values and we will get, that is A is equal to 296.82 meter per second. Therefore, velocity of the object is equal to m into a. That is 2.2 into 296.82. That is approximately 630 meter per second. Okay. Now we can move into another problem. Okay. An aircraft is flying at an altitude of 8 kilometer. At an altitude of 8 kilometer, where the ambient temperature is 250 Kelvin. That is temperature is equal to 250. Find out the Mach number. We have to find out the Mach number and classify the flow. That is, we have to classify the flow: subsonic, transonic, incompressible flow region, sonic flow region. Okay, next one, that is first one. If Mach number is less than 0.3, that is incompressible flow region. Mach number is in between 0.3 and 0.8, then it is subsonic flow region. When the Mach number is in between 0.8 and 1.2, which is known as transonic flow region. If Mach number is greater than 1.2, then it is supersonic flow region, and Mach number is greater than 5. What is the value? That is hypersonic flow region. We have to classify the flow. Okay, when the speed of the object, that is speed of the aircraft, is 30 meter per second, 300 meter per second, and 100 meter per second. Okay. Okay, first of all, we have to find out what is the value of velocity of sound. That is A is equal to, this question paper, it is not given that what is the medium. That is aircraft is flying. That is, we are assuming that air is the medium, air as a medium. Then gamma is equal to 1.4, and R is equal to 287 joule per kilogram Kelvin. 287 joule per kilogram Kelvin. Therefore, A is equal to, what is the value of A? A is equal to square root of gamma RT. Therefore, A is equal to square root of 1.4 into R is equal to 287 into T is equal to, what is the value of temperature? Temperature is equal to 250 Kelvin. That is equal to 250 Kelvin. That is A is equal to approximately 316.94 meter per second. That is the velocity of the sound is equal to 316.94 meter per second. Okay, we have to find out the value of Mach number. When the velocity of the object is 30 meter per second. We have to find out the value of Mach number when the velocity of the object is equal to 30 meter per second. That is case 1. Case 1. We have to find out the value of the Mach number. That is M is equal to C by A. That is M is equal to, what is the value of C? Velocity of the object is equal to 30 divided by A is equal to 316.94. Therefore, M is equal to approximately 0.0946. That is, M is less than 0.3. Therefore, flow is incompressible flow region. Flow is incompressible flow region. Okay, flow is incompressible flow region. Okay, next one, case 2. M is equal to C by A. That is, M is equal to, what is the value of C? In this case, value of C, object is equal to 300. 300 divided by 316.94. That is, value of M is equal to approximately 0.946. M is equal to approximately 0.946. We know that when the value of Mach number is in between 0.8 and 1.2, when the Mach number is in between 0.8 and 1.2, then it is transonic flow region. That is equal to transonic flow region. That is equal to transonic flow region. Okay. Next one, case 3. That is, M is equal to C by A. That is, M is equal to, what is the value? Velocity of object, that is equal to 100. 100 divided by 316. That is, M is equal to approximately 316.94. Approximately 100 divided by okay, it is a subsonic flow. So question can be changed to 1000 meter per second. 1000. What is the value? 1000 divided by 316.94. That is equal to 3.15. 3.15. Okay. That is, Mach number is greater than 1.2. That is, value is supersonic flow region. What is the value of, what is its value when velocity of the object is equal to 100? That is 100 divided by 316.94. That is 0.31. Mach number is in between 0.3 and 0.8, then it is subsonic flow region. Okay, it is 1000. What is the value? That is supersonic flow region. Okay. Okay, next one. Okay, next problem. An air jet gamma is equal to 1.4 and R is equal to 287 at 400 Kelvin has sonic velocity. That is, what is sonic velocity? That is velocity of sound, that is known as sonic condition. At sonic condition, what is the value? That is Mach number is equal to 1. At sonic condition, Mach number is equal to 1. Determine the velocity of sound at 400 Kelvin. So we have to find out the velocity of sound at sonic condition. That is velocity of sound at 400 Kelvin. At 400 Kelvin, velocity is the sonic one. Okay, sonic velocity is there. Therefore, determine the velocity of sound at 400 Kelvin. Therefore, velocity of the sound at sonic condition is, that is sonic velocity. Velocity of sound at stagnation condition, which is represented by A0. Reference Mach number, that is equal to m star. Maximum velocity of the jet, that is equal to C max. And stagnation enthalpy, that is equal to H0. And we have to find out CR. What is CR? CR is the Crocco number. We have to find out the value of Crocco number. It is given that an air jet gamma is equal to 1.4. That is gamma is equal to 1.4 and R is equal to 287 joule per kilogram Kelvin. Okay, joule per kilogram Kelvin. And temperature is equal to 400 Kelvin. That is, it has sonic velocity. It has sonic velocity at 400 Kelvin. That is sonic condition. At a sonic condition. Okay, at a sonic condition, what is the value of Mach number? M is equal to 1. M is equal to 1. Then C is equal to A. Then corresponding values is, that is a critical condition. Therefore, T is represented by T star. Okay, at a sonic condition, what is the value of Mach number? Value of Mach number is equal to 1 and the corresponding velocity of the object, that is C is equal to A. We know that M is equal to C by A. When M is equal to 1, C is equal to A. That condition is known as critical condition and which is represented by the symbol star. That is C star is equal to A star. C star is equal to A star and corresponding times are represented by the time. That temperature is represented by T star, pressure represented by P star and density is represented by rho star, etc. Okay, these values are already discussed in the live classes. Okay, T star is equal to 400 Kelvin. Determine the value of velocity of sound at 400 Kelvin. We have to find out what is the velocity of sound at 400 Kelvin. Okay, we know that first one, that is A is equal to square root of gamma RT. Okay, A is equal to square root of gamma RT. That is A is equal to square root of gamma is equal to 1.4 into R is equal to 287 into T is equal to, what is the value of T? T is equal to 400 Kelvin. That is 400 Kelvin is at a sonic condition. Therefore, temperature is represented by the critical reference, that is critical temperature. Therefore, T star. Therefore, A is equal to A star. A is equal to A star. Okay, that is T is equal to 400 Kelvin at a sonic condition. Therefore, it is the critical velocity, that is equal to critical velocity of sound, that is A star is equal to 1.4 into 287 into 400. That is A star is equal to approximately 400.9 meter per second. A star is equal to approximately 400.9 meter per second. Okay, first part is okay. Second one, velocity of sound at stagnation condition. What is the velocity of sound at stagnation condition? What is the velocity of sound at stagnation condition? Second formula, that is A0 is equal to square root of gamma R T0. A star is equal to square root of gamma R T star. Therefore, A0 is equal to square root of gamma R T0. Okay, we know that what is the value of gamma, what is the value of R, but we don't know what is the value of stagnation condition. Temperature. Okay, we don't know what is the value of stagnation temperature. Okay, we know that T0 divided by T. T0 divided by T is equal to 1 plus gamma minus 1 divided by 2 into m square. We know that T0 divided by T is equal to 1 plus gamma minus 1 divided by 2 into m square. At a sonic condition, it is given that at a sonic condition, sonic velocity, therefore, m is equal to 1. Therefore, T is equal to T star. Okay, m is equal to 1. Then T is equal to T star. Therefore, T0 divided by T star is equal to 1 plus gamma minus 1 divided by 2 into 1 square. Okay, that is equal to T0 divided by T star is equal to 2 into 2 plus gamma minus 1. Okay, that is T0 divided by T star is equal to gamma plus 1 divided by 2. Gamma plus 1 divided by 2. Therefore, T0 is equal to gamma plus 1 divided by 2 into T star. Okay. Into T star. Okay. Therefore, T0 is equal to gamma plus 1 divided by 2 into T star. That is equal to, what is the value of gamma? Gamma is equal to 1.4. 1.4 plus 1 divided by 2 into T star. T star is equal to 400 Kelvin. Okay, that is T0 is equal to 480 Kelvin. T0 is equal to 480 Kelvin. Then we can find out the value of stagnation velocity of sound. Okay, that is A0 is equal to square root of gamma or T0. That is equal to square root of gamma. Gamma is equal to 1.4 into 287 into, that is 480. Okay, then A0 is equal to approximately, value of A0 is equal to approximately 439.16 meter per second. 16 meter per second. A0 is equal to 439.16 meter per second. Okay, now third type. What is the reference Mach number? Third one. That is equal to m star. We have to find out the reference Mach number. We know that reference Mach number is a second kind of Mach number which is used in the case of high speed flow. Okay, that is m star is equal to c by a star. Okay, m star is equal to c divided by a star. In this case, it is sonic condition. Therefore, c is equal to a. Therefore, c star is equal to a star. Therefore, Mach number is equal to c star is equal to a star. C is equal to a. In this case, c is equal to a. Therefore, that is c star is equal to a star. Okay, therefore c star, which is represented by that time a star. That is what is the value of Mach number, reference Mach number, that is equal to 1. It is also 1. That is when m is equal to 1, then m star is equal to 1. Okay, when m is equal to 0, m star is equal to 0. Okay, it is already discussed in the previous classes. Okay, that is m star is equal to 1. Okay, reference Mach number m star is equal to 1. Now we have to find out what is the value of the value of maximum velocity of jet. Okay, what is the maximum velocity of jet? Maximum velocity of jet is equal to, what is the velocity of the object? Velocity of the object is equal to c. Then what is the maximum velocity of the object? That is equal to c max, which is find out from the steady flow energy equation. Okay, that is h0 is equal to h plus c square divided by 2 is equal to a square divided by gamma minus 1 plus c square divided by 2. When a is equal to 0, then c is c max. That is c max square divided by 2 is equal to, when c is equal to 0, then it is stagnation condition. That is equal to a0 square divided by gamma minus 1. Okay, a0 square divided by gamma minus 1. By using these two equations, we can find out the value of, maximum velocity of the jet. Okay, that is c max square is equal to 2 into a0 square divided by gamma minus 1. Okay, 2 into a0 square divided by gamma minus 1. Therefore, c max is equal to 2 into a0 square divided by gamma minus 1, the whole raised to 1 by 2. That is equal to the whole root of 2 into a0 square divided by gamma minus 1. That is represented by 1 by 2. Whole raised to 1 by 2. That is equal to 2 into, what is the value of a0? That is equal to 439.16 square divided by gamma is equal to 1.4 minus 1. The whole root. Okay, that is c max is equal to, maximum fluid velocity is equal to 981.99 meter per second, which is approximately maximum fluid velocity, which is approximately c max is equal to 981.99 meter per second. Okay, next one, maximum velocity of the jet. Next one, stagnation enthalpy. We have to find out what is the stagnation enthalpy. Okay, we can find out the value of stagnation enthalpy by h0. That is h0 is equal to c max square divided by 2. That is h0 is equal to c max square divided by 2. h0 is equal to c max square divided by 2. C max square divided by 2. Therefore, H0 is equal to, what is the value of C max? Maximum fluid velocity, that is equal to 981. That is equal to 981. 1 by 2 into 981.99 square. That is H0 is equal to approximately 482.15. 482.15 kilojoule per kilogram. Which is approximately 482.15 kilojoule per kilogram. Okay, next one. What is the value of Crocco number? What is the value of Crocco number? We know that. What is the value? This is the stagnation enthalpy. That is the fifth one and last one. Okay, we have to find out value of Crocco number. We know that Crocco number is the ratio between fluid velocity to maximum attainable fluid velocity. That is equal to, what is the value of fluid velocity? That is equal to 400 divided by maximum attainable fluid velocity. That is C max. C max is equal to 981. 981.99. Okay, that is CR is equal to approximately 0.408. CR is equal to approximately 0.408. Today we were discussed around 3 problems. Okay. This question is already asked in KTU, for KTU in December 2018. Okay, so very simple question. An air jet gamma is equal to 1.4 and R is already given. First of all, we have to find the velocity of the sound. Okay, A is equal to square root of gamma RT. Velocity of sound at stagnation condition, that is A0. A0 is equal to square root of gamma R T0. Reference Mach number, that is equal to M star, and the maximum velocity of the jet, that is C max, and stagnation enthalpy, that is equal to H0, and Crocco number, that is equal to CR. Okay, thank you.